Alright, so let's put it all together, and then I even have another little trick up my sleeve, right? Because take a look at what's inside here. This is, we usually want b parentheses x minus d. And so I don't quite have that. So I've got a lot going on. So why don't we fix that first? So we got 4 secant. If I pull that 2 out of there, what's going to be left behind is x minus pi over 2. And real easy check, just redistribute the 2, and 2 times x is 2x, and 2 times pi over 2 is pi. So we're all good to go. So the next thing we're going to consider is we're going to change that secant to its reciprocal, the cosine. We're going to graph the cosine and then use that graph to basically build my secant graph that we're after. All right, so after one period. So for this analysis, A is 1 and C is also 1. So, A is 4 and C is 1. All right, so we have an amplitude change and we're shifting things up by 1. So that's all the stuff impacting Y. Impacting X, well, B is equal to 2. So we have a new period, right, of 0 to pi. And D is equal to pi over 2. So we're shifting right pi over 2. So that's all the things that are impacting X. So like we did earlier in this chapter, we're going to take a look at what are all the major data points on cosine. Well, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then 1, 0, negative 1, 0, and 1. So those are the main data points on a cosine graph. So first we do multiplications and divisions. Let me change pens. So we're going to be multiplying all my y values by 4, and we're going to be dividing all my x values by 2, which means we're actually multiplying by a half. So when we do that, here's my new data. So we get 0, 1/2 of pi over 2 is pi over 4, pi over 2, half of 3 pi over 2 is 3 pi over 4, half of 2 pi is pi. So you can see that shrinkage of the period from 0 to 2 pi to 0 to pi. And then we're multiplying by 4, we get 4, 0, negative 4, 0, and 4. So we've handled the A and the B, all the multiplications and divisions. Now we're going to add 1 to all my y values, and we're going to add pi over 2 to all my x values in order to get that. So let me kind of sneak that down here. So we'll add 1 first because that's easier. 4 plus 1 is 5, and a 1, and a negative 3, and a 1, and a 5. All right, so I just added 1 to all my y values. Adding pi over 2, well, 0 plus pi over 2 is pi over 2. Pi over 2 plus pi over 4. If you still need to see that work, this is 2 pi over 4 plus pi over 4, which is 3 pi over 4. If we add a pi over 2 to a pi over 2, we have pi. If I take 3 pi over 4 and add it to pi over 2, that's a 5 pi over 4, right? Because again, we have 2 pi plus 4 plus 3 pi over 4. And then pi plus pi over 2 is 3 pi over 2. So there's all the main data points on this new cosine graph. So going to plot, right, we've got pi over 2, 3 pi over 4, pi, 5 pi over 4, and 3 pi over 2. Of course, we have negative pi over 2, negative 3 pi over 4, right, and negative pi, or we can keep going on here, right? We have 7 pi over 4, and then eventually we'd have 2 pi. Okay, so basically there's all our data points coming up in our thing. And in terms of the x-axis, excuse me, the y-axis, how about we go in steps of 1? So 1, 2, 3, 4, 5, 6. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. And then we can start point plotting. At pi over 2, we are 5. At 3 pi over 4, we are 1. At pi over 3, we are, at pi, we're at negative 3. At 5 pi over 4, we're at 1. And at 3 pi over 2, we're back over here at 5. And then we just keep repeating that pattern essentially. right? So it just keeps repeating. I think my scale's a little off there. I think we'd have a pi over 4 in here. We'd be back at 1. Negative pi over 4. We'd be at negative 3, and so forth and so on. Okay, so here's basically a sketch of our cosine graph. All right, equilibrium again is happening right here. So we have a a vertical asymptote at, looks like that would be pi over 4. We have another one at 3 pi over 4, and at 5 pi over 4, and at 7 pi over 4. We're at a low point when cosine is at a high point. We're at a high point when cosine is at a low point. And so there you go. There's pretty much 1 from pi over 2 to 3 pi over 2. There's basically what our classic secant graph looks like. Of course, if you wanted more, you just keep repeating that. But that's all we got to do. All right, and so the next one, let me go ahead and try to sneak that on here. Again, our first item up for bid is the fact that this inside, I have to pull a pi out, and we have that. So A is equal to 1/2. C is equal to negative 3. Right? That's impacting my y. B is equal to pi, so my new period is equal to 2, and D is actually equal to negative 1, because adding 1 means we're moving to the left 1. And so all my new data, remember this is for a sine graph, right? So for a sine graph, we have the quadrantal angles. Oops, I keep forgetting pi. Pi, 3 pi over 2, and 2 pi. For a sine graph, we're at 0, 1, 0, negative 1, and 0. And so we're first going to do all our multiplications and divisions, right? So we're going to multiply by 1/2, and we're going to basically divide by pi, which means we're actually multiplying by 1 over pi. So when I do that, we get 0. The pi's cancel out, leaving us with 1/2. The pi's cancel out, leaving us with 1. The pi's cancel out, leaving us with 3/2. The pi's cancel out, leaving us with 2. So you can see our period is from 0 to 2. Along the y-axis, we have 0, 1/2, 0, negative 1/2, and 0. So there's basically the A's and the B's. Now the C's and the D's, we're going to be subtracting 3 from all my y values and subtracting 1 from all my x values. So when I do that for this graph, let me sneak it down here. If we subtract 1, we get 0, minus 1. 1/2 take away 1 is minus 1/2. 1 take away 1 is 0. 3/2 take away 1 is 1/2. And 2 take away 1 is 1. So there's all our important x data. Our y data, we're at a negative 3. It looks like a negative 2.5, a negative 3, a negative 3.5, and then a negative 3. So when I go plot this data, what's fortunate for us is we have some pretty nice values for x. We don't have any pi's. They're basically in terms of halves. So how about we got 1/2 and 1 and 3/2 and 2 and 5/2 and 3. We got minus 1/2, minus 1, minus 3/2, and even a minus 2. And along the x-axis, we've got 1, 2, 3, negative 1, negative 2, negative 3, negative 4. So we're ready to start plotting. So one of my first data points on the sine graph, remember we're doing sine first, is negative 1, negative 3. Okay, so we've got that. And then on the next one would be, negative 1, negative 3, I'm sorry. Negative 1/2 and negative 2.5. So right about there. Then we have 0, negative 3. Then we have 1/2 and 3.5. And then we got 1 and negative 3. So this is just going to keep repeating that pattern, right? So we're going to be at a high point here, low point here, right? We're going to be at a low point, high point. So here is basically our graph, all right, of 1/2 sine pi of x plus 1 minus 3. Equilibrium, right, is here at -3. And so wherever I have an equilibrium, so at -1, at 0, at +1, at +2, and eventually at +3, right? Those are going to be all vertical asymptotes for the cosecant graph. And then we're at a high, if we're at a high point, that means the cosecant is at a low point. And when we're at a low point, that means the cosecant is at a high point. And there are a couple of periods at least for this new function. In blue is what's the 1/2 cosecant of pi x plus 1 minus 3. So that's with A, B, C, and D together. Do the sine and the cosine, do that analysis. Equilibriums is where we have vertical asymptotes. Highs turns into lows, and lows turn into highs for the respective graphs. That way you'll have all the important extrema, you have all the important vertical asymptotes, and you got yourself a nice sketch. All right, so that wraps that up. We're going to move on to curve fitting and start wrapping this chapter up shortly.